Assalamualaikum and hello everyone. We will discuss now Unit 2, Part 2, Vector Analysis. Content for Part 2 are the addition and subtraction of vector graphical method and addition and subtraction of vector component method. Now we are going to discuss on vector addition using graphical method. There are three ways by adding vector, which are triangle method, parallelogram method, and polygon method. In triangle method, when a vector B is added to vector A, the tail of vector B is connected to the head of vector A. The resultant vector C is determined by drawing an arrow that starts from the tail of vector A to the head of vector B. The magnitude and direction of vector C is determined by measuring the length of the arrow and the angle theta made by the arrow with the x-axis. In parallelogram method, when a vector B is added to vector A and B are drawn from the origin. Two dotted lines are drawn parallel to vector A and B. Both lines will converge at a point. The resultant vector C is determined by drawing an arrow that starts from the origin to the point where the line converge. Finally, the magnitude and direction of vector C is determined by measuring the length of the arrow and the angle theta made by the arrow with the x-axis. Polygon method is used when adding three or more vectors, which is similar to triangle method. Let us add the vector given below. From the figure, the resultant vector D is obtained by drawing an arrow from the tail of the first vector to the head of the last vector. The magnitude and direction of resultant vector D is determined by measuring the length of the arrow and the angle made by the arrow with the positive x-axis. Trigonometry is a branch of mathematics that studies relation between the side length and angles of triangles. There are law of sines, law of cosines, and Pythagorean theorem. These laws can be used to determine the magnitude or direction of vector or resultant vector when two vectors are added together. Let us take a look at example 6. Using graphical method, compute the magnitude and direction of D if D equal to A plus B. Given A equal to 10 meters negative 30 degrees and B equal to 20 meters bearing 90 degrees. How do we solve the problems? First, we need to determine the position of each vector in the xy plane and draw the resultant vector using a triangle method. From the diagram, the magnitude of D can be determined using law of cosines. After calculation, we managed to get the magnitude of D equal 29.1 meter. Next, the direction of D can be determined using law of cosine. Finally, the answer is 9.89 degrees below the positive x-axis. Now we come to the component method. Let's learn about vector in two dimensions. Consider a 2D vector where vector A is the magnitude of vector and theta is the direction of the vector with respect to the positive x-axis. Take A to be situated in the first quadrant of the xy plane, as shown in figure. Vector A can also be expressed as the sums of two vectors. Vector AX parallel to the x-axis, vector AY parallel to the y-axis, where AX and AY are called the component vector of A. I and J are unit vector along with x, y-axis. From the figure, magnitude of vector AX is the x components of A given by AX equal to A cos theta. Meanwhile, magnitude of AY is the y component of AY equal to the A sin theta. Therefore, magnitude of vector A is given by the vector A equal the square root of A squared plus square root of AY squared. And the direction of vector A is given by the theta equal to the arctangent AY over AX. Now let us try example 7. Resolve vector A equal to 10 meter negative 30 degree and B equal to 10 meter negative 120 degree into their rectangular component. Next, let us discuss example 8. First, write the rectangular components for vector A and B. Then, try to add components according to their direction. Add the components according to their direction to get the components for resultant vector C. Finally, calculate the magnitude and direction of the vector using the resultant components values. Next is example 9. Firstly, from the given equation, identify the locations of these vectors in the xy plane. Draw the given vector, vector A in the first quadrant, vector B in the third quadrant, vector C in the second quadrant, and vector D in the fourth quadrant. Then, calculate the rectangular components for each vector. Next, combine the components according to their direction to get the components of resultant vector E. Then, calculate the magnitude and direction of the resultant vector. We have reached the end of Unit 2. We hope you understand the lesson and enjoy the video. Please check for more videos coming soon. Till meet again. Bye.